example 1 for work. A man pushes a 50 kg refrigerator horizontally at constant speed for about 14 meters along the floor. The coefficient of friction is 0.4. How much is the work done by the man? Okay, so this is the M of refrigerator, this is the displacement, this is the mu K, coefficient of friction, and then given here a constant speed. Okay, so last time, if you remember in the lecture, we have discussed when does work done equals to 0. Okay, so one of the keyword is when there is a constant speed. Okay, so kita kata constant speed, work done equals to 0. Does that means the work done by the man equals to 0? Okay, so the answer is no. The total work done on the system is equals to 0. But by the man is not equals to 0. Okay? Okay, so the reason being is that S is moving to the right. So there is displacement. Okay, the man is doing positive work done. So he is pushing the refrigerator in the direction of displacement. So this is positive work done. But at the same time, there is friction force opposing the motion. So the work done by the friction force is negative work. This one positive work done, this one negative work done. Okay, so in order to get total work done equals to 0, the magnitude of the work done by the man must be equals to the work done by the friction force. So nilai dia sama, dia akan cancel out, work done kosong, tapi objek masih lagi bergerak. Okay, so the question is asking for you to calculate the work done by the man. Okay, so don't directly write 0. Okay, because 0 is not the answer for the work done by the man. Okay, so to calculate the work done by the man is equals to the external force applied by the man, okay, times with the displacement and cos the theta. So in this case, force to the right, S to the right, so the theta is equals to 0 degree. Okay, we don't have any information about the force by the man, but we know the displacement, and then cos 0 is 1. So 14. So where can we get the information or the value for the force applied by the man? Okay, so we can get the information from the keyword constant speed. Here we can apply the Newton's law. So along X, initially we might write as equals to MA. Okay, because we can see there is a motion going to the right, MA. But from the constant speed, when V is constant, A is equals to 0. Okay, so from here, it will become Fx equals to 0. Okay, so focus on the forces along X. Forces along X, we have F and Fk. Okay, so write F minus Fk equals to 0. F equals to Fk. Okay, so here we can see that the force has the same magnitude as the friction. Okay, so force equals to friction. The formula for friction is mu Kn, where mu is the coefficient of kinetic friction, 0.4. But the problem is we don't know N. Okay, so we have another unknown. Okay, don't panic. Just write another equation for the Fy. Fy, no motion along Y equals to 0. So the forces along Y is N and W. Okay, so N minus W equals to 0. So N equals to mg. Right, so from here we can expand the equation. In this case, N equals to mg. So mass yang mana? Mass of the refrigerator lah. Okay, so 0.4, refrigerator 50, times 9.81. So here we will get 196.2 Newton. Okay, so that is the magnitude of external force. So just substitute into the formula 196.2 times 14. So we got 2746.8 joule. Okay, I put the positive sign over here because the man is doing a positive work done. Okay, so I repeat, the magnitude of force equals to the kinetic friction, and then the formula for kinetic friction is mu k. N is equals to mg. Okay, so then we get positive. Okay, let's say the next question is to find the work done by the friction force. Work done by friction force. Okay, because we know that F equals to F, friction force, so we can directly say that the work done by the friction is negative. Okay, work done by friction always negative.